morning everyone. This video is the continuation of cylinder. In previous video I had done around 5 sums. Let's continue some more sums and slightly difficult ones which we deal with cylinder. Question number 5. How many cubic meters of soil must be dug out to make a well 20 meter deep and 2 meter in diameter? So since you have dimensions given 20 meter and 2 meter, I'll be using different dimensions so that you can try question number 5A yourself. It says that 20 meter deep. So if you look at the figure, a well is in form of a cylinder. Well is in form of cylinder. It is beneath the ground. So we have depth, and depth is considered as the height. In book it's given 20, so I'm taking 21 meter. And diameter is given, which is equal to 2 meter. I'm taking it as 3 meter. Question says that how much soil must be dug out. So from this cylindrical part, when we dig a well, whatever soil is taken out has to be thrown at the side. So you need to calculate the volume of the well. So you write down the given values first. Height, which is equal to 21 meter. Diameter is given, which is equal to 3 meter. And since we have diameter, so you cannot do calculation, you need to find radius. And radius is half of diameter. You divide diameter by 2. Soil must be dug out. So volume of cylinder. Volume of cylinder, within bracket you can write well. Formula is pi r square h. And I told you this whole chapter, mensuration is based on formula, so you need to memorize it. Pi 22 upon 7, radius we got 3 upon 2, 3 upon 2, since it is square so we write 2 times, height is 21. Now you have to simplify this to get the volume of well, the amount of soil which is dug out. 7 3 times 21, 2 11 times, multiply the values. 3 9 into 3 is 27, 27 into 11. It is 297 divided by 2. 148.5 meter cube. This is the amount of soil which has been taken out to make the well. Question has second part. Question says that if inner curved surface of the well is to be plastered at the rate of 50 per meter square, find the cost of plastering. So you need to understand which portion of the well is plastered. This inner part is to be plastered from all around. All around. So we are talking about curved surface area. Curved surface area of well. Or you can write cylinder. It is 2 pi RH. And once you know the curved surface area, you can calculate the cost of plastering. 2 into 22 by 7, radius is 3 by 2, height is 21. 7 3 times, 2 cancels, You multiply this 2 into 3 into 3 is 9. 9 into 2 is 18, 19 meters squared. Now we calculate cost of plastering. Cost of plastering is equal to, it is so simple, rate of plastering multiplied by curved surface area, which has to be plastered. Rate, let's take it as 50, 198. You multiply this, you get the cost of plastering. So first part, how much soil must be dug out, that is volume of the well. Second one, cost of plastering means the curved surface area has to be plastered. So you find curved surface area first, then calculate cost of plastering. So this is example for question number 5. Question number 6 is an important question. A roller. You must have seen a roller which is used to flatten the surface. Normally they use it to make the path road, which has to be labeled, has diameter 0.7 meter. So I'm changing the value 0.7 meter. I can write it as diameter as 2.1 meter. And its width is 1.2 meter. Width means height. It is 1.2 meters, so let's do 2.4 meter. And it has to be kept horizontal like this, roller. So if you keep it this way, the width is nothing but height. It is similar. If this cylinder is kept vertically, this length will become height and diameter remains the same. Find the least number of revolution that roller must make in order to label a playground. So you have a playground which has to be labeled. The roller has to roll it on the surface. So how many times it is going to rotate, you have to find. So you need to understand simple concept. When the roller is moving, what part of the roller is in contact with the ground? It is the curved surface part. When it is rolling, the outer curved surface part comes in contact with the ground. So you need to calculate the curved surface area first. So you have diameter, find radius. 2.1 divides by 2, which is equal to 21 divides by 20. Leave it, remove decimal from here, leave it in fraction. Curved surface area of roller. It is 2 pi RH. 2 multiplied by 22 by 7. Radius we know that is 21 by 10. And height we have taken as 2.4. It is meter squared. You should not simplify this because you are finding number of revolutions. And this roller has to go on the playground. Rolling on the playground. So we calculate area of playground. Because roller has to go on over the ground. And it is in form of rectangle, so it is length multiplied by breadth. Length is given 120 meter. Breadth is given, which is equal to 44 meter. Leave it in this form. Curved surface area, you write like this. Area of playground, you leave it with multiplication. Now we have to calculate number of revolutions. Number of revolutions equal to The playground has to be labeled, so it is kept at numerator. Area of playground. Divides by curved surface area of roller. So it is 120 into 44 divides by 2 multiplied by 22 upon 7 into 21 upon 20 multiplied by 2.4. This has to be simplified in order to get the number of revolutions. We reciprocate this. 120 into 44 into 7 into 20 divides by 2 into 22 into 21 into 2.4. Remove decimal, put 0 and then cancel it. 22 2 times 44, 7 3 times 3 40 times 2 20 times. This is divisible. You can cancel again. 2 5 times, 2 12 times, 10 6 10 3. So you are left with 10. You are left with 2, you are left with 10, you are left with 5 divides by 3. You do the multiplication, you get the number of revolutions. This calculation, please do it yourself. You'll be getting answer in mixed fractions, so you need to make it a whole number. Or I'll do the calculation. 100, 200, 200 into 5. It is 1000 divides by 3, 3, 3, 3, 1 by 3. And number of revolutions cannot be in mixed fraction, so we write down the whole number. How many times the roller is rotating? 333 times all over the playground. Similarly, you try question number 6 from the exercise. Question number 7 is easy. You can try it yourself. Question number 8. And it is an important sum. It had come in ICSE 2018. The circumference of cylindrical base is 132 centimeter. So I'll change the value. Circumference of base of cylinder, which is equal to 132. So I'll change the value 264 meter, and its height is 25. Okay, let's take it as centimeter, and its height is 25 centimeter. Height is given 25, so I'll change it and write it as 50 centimeter. Question says that find the radius of cylinder, and second part is volume. You have a cylinder. Circumference of base means this part, this curved part is circumference of cylinder. And if you look at this part, it is in form of circle. So we use this circumference to calculate radius. That is the reason why circumference of base is given. Circumference of base is equal to circumference of circle, because the base of the cylinder is in form of circle. So we substitute the value here, 264. Circumference of the base of cylinder, that is circumference of circle. You need to recall your class 9 maths. Circle, and circumference of circle is nothing but 2 pi r. So we calculate radius from here. 264 equal to 2 into 22 upon 7 into radius. Cross multiply. 264 into 7 equal to 2 into 22 into r. 264 into 7 divides by 2 into 22 equal to r. This is the radius. Cancel it. 2, 1, 3, 2. It is divisible by 11. 11 2 times, 11 1, 11 2 times, 2 6 times. 7 into 6 is 42. We know the radius. And once you know the radius, you can get the volume easily because you need height and radius. Volume equal to pi r squared h. 22 upon 7, radius we got 42. 42, height we know 50. So you need to simplify this. 7, 6 times 42, 22 into 6 into 42 into 50. Do the multiplication, you get volume as centimeter cube. So similarly, you try question number 8 from the exercise which had come in ISSC 2018. I'll be doing same type of sum, that is question number 9, and it is another important question. The area of curved surface of cylinder. So curved surface area of cylinder is given, which is equal to 4400. Circumference of its base, circumference of base 110. Question says that find the height of the cylinder and volume of the cylinder. So you need to look at these two given values. Curved surface area 2 pi RH. If you look at the formula out there, both radius and height are unknown. Circumference of base 2 pi r. You have only one unknown variable. Means that we use this given value to calculate radius. Circumference of base, and base of the cylinder is in form of circle 110. So we write down the formula. 2 pi r equal to 110. Substitute pi, cross multiply, make radius the subject of formula, cancel it. 2 55 times 11, 2 times 11, 5 times, you get 35 upon 2. We know the radius, and once you know the radius, use curved surface area to calculate. First answer, height. Curved surface area of cylinder 4400. Write down the formula here. 2 pi RH 4400. 2 multiplied by 22 upon 7. Radius we got 35 upon 2. Height is unknown. Substitute. And then If you can cancel on the left hand side, it's well and good. 7 5 times, 2 cancels. 22 into 5 into height equal to 4400. Make height the subject of formula. 4400 divides by 22 into 5. You can cancel it now. 22 2 times 5 40 times. So height of the cylinder is 40 centimeter. You know height, you know radius. Second part, volume. Volume equals to pi r squared h. 22 by 7, radius is 35 by 2. 35 by 2, height is 40. Now you simplify it. 7, 5 times 2, 11 times 2, 20 times 11 into 5 into 35 into 20 will give you the volume of the cylinder. Multiply and then write down the answer. So please do question number 8, 9. Question number 10 is similar. Then you have question number 12. Question number 12. Find the ratio between total surface area of cylinder to its curved surface area, given that height and radius are. So when you are asked to calculate ratio, you need to do calculation in 2 steps. First case and you write second case. So you have height given, which is equal to 7.5 centimeter. Radius is given, which is equal to 3.5 centimeter. Second case, height will be 7.5 only and radius will be 3.5. Question says that find the ratio of total surface area to curved surface area. So in first case you calculate total surface area. Total surface area, you have to write down the formula. 2 pi RH plus 2 pi r squared. Simplify this mathematical formula. Take 2 pi r common, you get h plus r. Leave it like this. You should not be substituting the value. Curved surface area 2 pi RH. Now we find ratio of total surface area to curved surface area. You write down the formula first. Curved total surface area is 2 pi r, h plus r is 2. Curved surface area is 2 pi rh. After writing this, you can cancel directly or you can make it in fraction, antecedent and consequent. So I am cancelling here only. 2 pi r cancels. Height, we got 7.5 plus radius is 3.5 is 2. Height is 7.5. Add it up, 10, 11 is 2. 7.5. You should not leave ratios in decimal. So it is 110 is to 75. You have to reduce it because both are divisible by 5. 5 2 times 5, 2 times 10, 5 1, 5 15 times. It is 22 is to 15. Ratio. Or you could do calculation with fractions like this. 2 pi r h plus r, 2 pi rh, 2 pi r cancels. Then you substitute 7.5 plus 3.5. 7.5. 11 divides by 7.5, remove decimal 0, then cancel it. 15, 22, which is equal to 22 is to 50. To calculate ratio, so please do try the sums which I asked you to do. It is question number 5, 6, 8, 9, 10 I did with same value. 10 you have to do. You can do number 12 with different value. So please do the sums which I ask you to do. The more you practice, calculations will become easier. The most important thing in this mensuration is to memorize the formula and calculation. If you are good with memorizing and write the correct formula and you have problem with calculation, that will be a trouble for you all. So please do practice. Thank you. Stay safe.